differentiation of y equals ln x or ln x. Y equals ln x. Ln, which stands for natural logarithm, is equal to log of base e. We can write y equals log of base e x. Log of base e x, this function is a logarithm function. We can convert logarithm to exponential functions. They have inverse relationship to exponential function. So the way it works, you raise e to the power of y. So that's raise. And then the answer will be equal to x in this case. So that will be equal to x. So that's the relationship. That's how you convert logarithm to exponential. Okay, so let's do that. We've got e. So we write e down. We're going to raise it to the power of y. So we put y there. And that be equal to whatever it's in here. In this case, x. So this is now exponential function. And that is a logarithm function. We use logarithm to solve exponential. And then we use exponential to solve logarithm. Let me write this again. X equals e to the power of y. If I was to differentiate, if you differentiate x with respect to x, you get 1. Or put it this way, I could write my differential here by saying the x divided by the y, the x over the y, that will be equal to e to the power of y. If you differentiate exponential function, you get the exponential function back. Now, but I do not need the x, the y. I need the y, the x. So I need to rearrange this. This is over 1. What I need to do is flip this, and I need to flip that. The y by the x equals to 1 over e to the power of y. So now I've got my dy dx. But dy dx now, which implies that dy dx will be equal to 1 over x. It's actually 1 over x times the differential of x times the x over the x. The x over the x is 1. Because if you differentiate x, you just get 1 with respect to x. So in this case, the differential of ln x, if you have y equals ln of x, the y, the x equals 1 over x. So that's the differential of ln x. So in general, if you have y equals ln of a, where a is a function of x, then the y, the x, will be equal to 1 over a. As you can see, 1 over x for the y dx for that is 1 over x times the x dx. But because we're differentiating ln x, this will be times the a over the x. So this is the key to doing differentiation of ln a. So let's do a quick example in this case. If y equals ln 3x minus 5, then the x will be 1 over 3x minus 5, because that's your a. Your a is 3x minus 5 times differential of 3x minus 5. If you differentiate a constant, you get 0. If you differentiate a linear, because that's to power 1, that's a linear, you get, if you differentiate 3x, you just get 3. So that would be times 3. When differentiating y equals x to the power of n, then the x equals n x to the power n minus 1. So that's what we've used to differentiate this one. Because x is to the power of 1. 1 times 3 will be 3. And then you get x to the power 1 minus 1. 1 minus 1, which is x to the power of 0. So that would be x to the power of 0. X to the power of 0 equals 1. So that 3 times 1 is still 3. dy dx will be 1 over, well, 3 by the way, because that's 3 times 1, and this is over 1, over 3x minus 5 for dy dx.